So to build on what you guys, the apparent functions that you guys have learned, we're going to be talking about transformations. Now, transformations can be given to you in two different ways, and I've seen, on the SAT or the ACT or various math resources or even coding languages, sometimes they will deliver transformations instead of into the equation. Sometimes they will put them in function notation. So, in this system of notating things, they would say something like, okay, y equals f of x, and when they say y equals f of x, that's their way of saying, I'm talking about a function called f. Like, think of the f of x as the name tag of the function. And then they will place all of the transformations for the function into the name tag. And then that gives them the freedom to try different functions in there, but keep the same transformations. So this is a helpful way of, expressing a function. And when they're talking about the transformations, they use these common letters, A, B, C, and D. Okay, now, a C and D are pretty straightforward. Like if you add a number at the very end of the equation, you're shifting that function up and down. So the D value is shifting it. It's a vertical shift, an up and down shift. And it follows its sign. Plus goes up, minus goes down. Okay. The C, adding or subtracting something with the x or inside the function, that is a shift to the left and right. And everything that's with the x, everything that is horizontal with the x, left and right, those changes are always backwards. So that C shift, that will go against its sign. So a plus will go to the left, a minus will go to the right for this with the x adding and subtracting. And then A and B cause vertical and horizontal stretches and compressions. So the normal rule for A, if you have a multiplier in the very front away from the x, not with the x, then that's a vertical stretch or compression. And that's the rule is that if that A multiplier is greater than 1, that's a stretch. If that A multiplier is between 0 and 1, it's a compression. So it's vertically stretching those, pulling them up and down, or it's vertically compressing them, like pushing them toward the x-axis, okay? And then last, we have the B multiplier. Now, the B multiplier is a number that's multiplying with the x in the function. So it's inside parentheses with the x, and that multiplier is backwards again. So if the B multiplier is above 1, well, that's not a stretch because it's backwards, so that causes a horizontal compression. Okay, it's horizontal because it's with the x. Everything that's with the x is horizontal. And it's a compression because it would be backwards. Everything that's with the x is backwards. Okay? So here's a table to kind of help you make sense of that. And like I said, sometimes they'll give you those transformations in function notation, so with the f of x part, and sometimes they'll put them into the actual equation itself. So I gave you some examples of both types of deliveries here. So on these first two examples, we have the transformations inside of function transformation or function notation. So the normal part of the function is the f of x, the part that I highlighted in blue, and then everything else is some kind of transformation. I want you to tell me what kind of transformations these are. Okay, so here I'll do this first example with you. We have adding and subtracting occurring, and then we have a couple of multipliers to deal with. Okay, so let's pick them apart one at a time. I think it's easier to start with the things that are not in parentheses, the things that are not with the x, and those are vertical changes. Okay, so adding at the end is not with the x, so it's vertical. So this is a vertical shift. So it's a shift up 1. Right? Things that are away from the x are straightforward. They follow their sign. They follow the normal rules. It's a shift up 1. Okay, so the plus 1 is an up 1 shift, and then the minus 2, we'll go ahead and deal with that while we're at it. The minus 2, is that with x or away from x? That's with x, so that means it's a horizontal transformation. Yeah, it's going to go to the right. Right 2, okay? Your options are left and right, and remember, everything with the x is backwards, so it goes against its sign. Right 2. Okay. Now we've got the 2 and the 3 to deal with. So we'll start with the 2. Outside, away from the x, that's a straightforward rule. The rule is above 1 is a stretch, between 0 and 1 is a compression. So what is this? It's a stretch, and it's away from x, so it's vertical. So we're going to call it a vertical stretch. And then I want you to identify the factor. So by a factor of 2. Okay. When we start graphing these, you're going to need to know the factor, because that factor is what you're going to multiply into the values of the graph. So this is a vertical stretch by a factor of 2. And then the 3, okay, is the 3 inside with the x, or is it outside away from the x? It is inside with the x. And you might be like, well, it's not in the innermost parentheses. That's not really the point. It's inside of the function. See, it's within f. It's inside of f where the x is at. And I have the second set of parentheses there to separate the shift from the multiplier, but it is inside. So it's horizontal. And so we would say this is horizontal. And then what is it? Is it a stretch or compression? It's a compression. You would think it's a stretch because it's more than 1, but remember, everything with x is backwards. So this is a horizontal compression. And what is the factor? By factor of, and here we go, this is where it gets crazy, by a factor of 1/3. Where did I get you 1/3? The reciprocal. Okay, so remember, things that are with the x are backwards. So that factor, that compression factor, it's the reciprocal of that number. All right. So just like the -2 sent it to the right 2 because it's backwards, it's with the x. The times 3 actually become like when I actually calculate it or graph it, it's a times 1/3 because it's backwards when it's with the x. Okay, so see if you can do that second one on your own, and then I'll show you my answer in a moment. All right, as you finish up, check your answers up there. We've got start with the easy ones. You got the -2 at the very end. That's away from the x, so that's just an up and down shift. It's down 2 because it's minus. Okay. And then you got the +1 with the x, so that's with the x, so it's backwards, so that should send it to the left 1, okay? The negative and the 1/2 are separate transformations, so we haven't talked about the negative yet. You've seen it before, though. That causes a reflection. What kind of reflection is it? It's a horizontal reflection, because it's with the x. Everything that's with the x is horizontal, okay? So that's a horizontal reflection, and any horizontal reflection is across the y-axis. You know, and like, think about that. We've got, if I'm reflecting something horizontally, that's a sideways reflection. You know, so the actual dots they're getting reflected across, like a horizontal movement where they land is sideways from where they were. That's across the y-axis, okay? So horizontal reflection is across the y-axis. A vertical reflection would be across the x-axis, okay? So that negative is what causes that. So these next two examples are, we have the transformations within an equation itself, not just within the name of the function. So see if you can identify what the equation is. Here on this first one, I'll help you out here. The x and the cubed are the parent function, and everything else is a transformation. So tell me what the parent function is, tell me the name of the parent function, and tell me what the transformations are. Okay. So we've got x cubed. That's the cubic function. And then we've got a couple of transformations in there. Some adding and subtracting, and then a multiplier. So we've got up 5, right 2, and then the 3, that's away from the x. It's not in parentheses with the x, so that's vertical. It's greater than 1, so it's a stretch. And it keeps its own factor. Stretch by a factor of 3. So there's the first example. Try both of them on your own. Check your answers up here. All right, so that second one's pretty straightforward. Down 3, right? And then the +1, I know it's not in parentheses with the x, but it's clearly like in little font size in superscript position up in the exponent spot. So it's clearly with the x. So that's a sideways shift left 1. Goes against its sign. Okay, see if you can do these next 4. Number 3 and 4 are more examples of transformations within an equation. And then the next 2 examples, the graphs, I want you to identify the name of the function, the parent function, and see if you can write the equation. Like identify the transformations that you're seeing, and see if you can write the equation of those graphs. All right, then we'll do the domain and range at the bottom together. So give those next 4 a try on your own. All right, so just a few things to point out for these. What's tricky about this number 3 is the 3 that's in the root. It's with the x, so that's horizontal. It's multiplying, so that means it's not a movement, it's a stretch or compression. And since it's with the x, it's backwards. You'd think a 3 was a stretch, but everything's backwards with the x, so it's a horizontal compression. And then furthermore, it's backwards, so it's a compression by a factor of 1/3, the reciprocal of that 3. So our compression factor is 1/3 there. Okay. And then on number 4, just want to point out to you, be careful where the root ends. So this root extends over the -1, so that means that -1 is a left-right shift. In this case, it's to the right because it's minus. But it doesn't extend over the 4, so that means that's an up and down shift, that 4 is. Okay, so just pay attention to how far that root stretches. Okay, so on these graphs, these are pretty straightforward. You'll notice on the graphs I have these red dots there, and that's just me checking to make sure that it hasn't gone through any kind of stretch or compression. Okay, so I know because I've done parabolas for a while, and when I say I mean you guys also have done parabolas for enough time to know that where these 5 points normally land. It's like 1, 1, 2 squared is 4. So these red dots are where those parabola points normally land, and I'm checking those to make sure it hasn't been stretched to somewhere else. Okay, so same thing with the square root curve over here. I'm checking to see, okay, the square root of 1 is 1, the square root of 4 is 2, just making sure all my dots haven't stretched to land somewhere else. Also, apologies about the weird axis numbers. I don't know what that's about, but it should be, it's fairly obvious. It should be, this is negative, this is negative. So here, we'll fix that. Negative, negative. There we go. Okay. All right, let's look at the domain and range. So let's just review domain and range here. They're asking us to do domain and range for this little piecewise function in interval and set notation. So remember, the domain is the left and right. So in a sense, it's almost like you're checking off for the domain, you're checking off all of the x values that have a place on the graph somewhere. So you're working along the axis and just checking all of these x values have a place on the graph in this zone right here. And we're checking off all of them. So we're not coming across ever really a value that doesn't have a place somewhere. All of those have a spot all the way up until 5. Okay? And does 5 have a spot on the graph? No. Well, how do we know the answer is no? Because that open circle. Do you see that open circle right there? That open circle means it gets infinitely close to 5, but exact 5 does not have a spot on the graph. It doesn't actually hit 5. Okay, it's like 4.999999999, so on and so forth. So our domain in set notation is x such that x is what? It looks like 5 is the edge, the boundary. Is it everything above 5 or below 5? Below 5, so less than 5. Is it equal to 5? No, it's not less than or equal to, just less than. And then, of course, our interval notation would be negative infinity to 5 with a parentheses on the 5. So that's how we treat the domain. You're checking off x-axis numbers to see if they have a place on the graph and where. And you're expressing all of the x values that have a spot. And then the range, you're doing the same thing with the y-axis numbers. You are checking off mentally the y-axis values that have a spot on the graph. It's very clear that none of these y-axis numbers at the bottom have a place anywhere on the graph. The graph doesn't go down here. in this zone. So none of these are going to be included. What is the lowest x or lowest y value that has a spot on the graph? 0, right here, 0. And then 1, 2, 3, okay, all of these have a spot. But then as soon as you get past 3, none of these have a spot on the graph either. So really it's just from 0 to 3. Now question, you said 0 has a spot on the graph. You're right. There's no dot here, but you know, we've seen this shape, the absolute value shape does actually hit that point. So there's no tricks there. It's not an open circle or anything. Okay. Does it actually hit 3 though? Does 3 have a place on the graph?
Yes and no.
Yeah, you're kind of like leaning yes and no. I can see you're probably leaning no because of this open circle, but that's okay. 3 is covered by this dot. The y value of 3 is covered by this dot right here. Okay? So 3 does have a spot. Okay, so our range will go y such that, and since it's got an edge on the bottom and top, we'll use a compound inequality. It's everything, the y's are everything between 0 and 3. So that's how I structure my compound inequality. I do the y in the middle, and I do the lower edge and the upper edge, 0 to 3 with the y in the middle. And then I put in my inequalities. Y is greater than 0 or equal to, but it's less than or equal to 3. Okay, and those inequalities should be pointed in the same direction when you're writing a compound inequality. Let's close out with a squiggle bracket here. And then interval notation, obviously 0 to 3. Are we good with that interval? Is that a correct interval? No, what's wrong with it? I should have a bracket. Where? For both. Okay, it does hit 0. An absolute value point does actually make contact, so 0. And then it does hit 3 because of this closed dot up here. So brackets. And you might be like, Mr. Wagner, does that really count? Like, are you really going to count off if we mess that part up? Yes. Yes, it makes the difference, and I will count off. So make sure you get the bracket and parentheses correct. It's not both. They're not interchangeable. They mean different things. So get it right. And if you're not sure, ask about it. Okay?